Hello and welcome. I'm going to walk you through our process in designing and building a motorized Etch-a-Sketch module. First, our parts and components. We built two versions of this project. First, a CNC-controlled Etch-a-Sketch, and second, a master-slave system where one Etch-a-Sketch would repeat the drawing made on another. The parts used were as follows. NEMA 17 stepper motors driven by DRV 8825 stepper motor drivers, 100 pulse per rotation DC5 rotary encoder with A and B phases. We custom designed and 3D printed the elements used to mount the parts around or on the Etch-a-Sketches. We advise you do the same, as you may be able to come up with a better or more stable method than we did. And duplicating our method of mounting the parts is not as important as making sure that you have the correct parts in the first place. We use two different control methods for each version of our project. For the CNC project, we used an Arduino Uno flashed with Gerbil processing software. For the master-slave project, we used a PSOC 5 and programmed a system to process the encoder commands and output motor commands. Here is the schematic generated in PSOC Creator and a logic diagram of our coding used to program the PSOC to control the master-slave element of this project. And here we have the layout that Gerbil utilizes on an Arduino Uno to connect to the motor drivers. As a result, we use this layout in our CNC project. Here is a close-up of just the DRV 8825 drivers and the pinout and connection layout that we used for both parts of our project. Here we have footage of us practicing and demonstrating the CNC aspect of our project. Because we generated the actual G-code in a separate program, specifically Fusion 360, we started here by creating a rectangular frame. This would act as essentially a drawing board within which we would make other drawings to generate G-code from, and this would help us calibrate the dimensions of our drawings. The assignment initially had us draw a line at 60 degrees at 15 centimeters in length, a rectangle of 5 centimeters by 10 centimeters in dimension, and a circle of 10 centimeters in diameter. Here you can see we begin running G-code through the Arduino and it executes the program with the motors quite well. Some problems that we had were with the Etch-a-Sketch itself. There is a little bit of lag that arises when you are using the Etch-a-Sketch because as you change directions, tension in the fishing line essentially inside the Etch-a-Sketch changes direction. There's a moment of slack, and as you can see, every drawing seems to have a little bit of lag as a result. Once the rectangle finishes here, you see the circle does not come out quite perfectly for that exact reason. A little bit of slippage in the knobs, a little bit of slack in the fishing wire inside the Etch-a-Sketch does cause the circle to come out slightly oblong on the corner, right about there actually. It also causes the sides of the circle to flatten out slightly as it goes around. This is not a huge problem. It is, however, more or less unremovable in the system. There's no real way to get around it. Another problem that we had was in getting the knobs to stay gripped to the motors that we mounted on them. This bit of footage shows us testing out the master-slave part of our project. As you can see, we started initially with just straight lines back and forth, but eventually moved on to testing the system's ability to replicate curved lines, which it does very well here. It is, however, limited. If you turn either of the knobs too quickly at the same time, it aliases the system and the image does not come out exactly as intended. It will sometimes not make as many steps as necessary. It may not follow the curve exactly. For example, a smooth curve will turn into a straight line at 45 degrees. While recording this footage, you can see that I got bored with doing generic shapes and decided to try my hand at text. This is, in some cases, more difficult to achieve on the Etch-a-Sketch than regular, just random shapes, but the Etch-a-Sketch with the motors mounted on it, as you can see, does follow quite well. An advantage of this system is the actual human limitation involved. It's very easy for a person to do a straight line very quickly, and the Etch-a-Sketch is able to follow that quite well. However, a human is not able to do a curve on an Etch-a-Sketch very quickly, and that forced slowness gives the Etch-a-Sketch system an opportunity to stay caught up with it and follow the curve very accurately. The image replication is not perfect. There are moments where lengths are not perfectly followed. This could be for a number of reasons: knob slippage in the mechanical aspect or aliasing in the digital aspect. However, the differences are extremely small and seem to occur only in isolated moments and do not persist throughout the rest of the drawing very far. Right now, I'm making an attempt at a number of curved or angled lines, and again, the Etch-a-Sketch system follows that line very well. To test the system's ability to tolerate the error born into the Etch-a-Sketch and the slack generated when changing direction, we also created a set of G-code that outlines the gears we use to pair the encoders to the Etch-a-Sketch. This involves a lot of rapid changes in direction, and as you can see, as the G-code runs through, it gets the approximate shape correctly, but there is a lot of error and a lot of drift as it goes back and forth. The Etch-a-Sketch itself is not really quite able to keep up to the motions of the motor and create the desired image. Lastly, mainly for fun and also to mess with our professor a little bit, we tried out creating G-code for text. In this case, we are demanding an A grade from our professor. He found this quite entertaining, and I myself am very satisfied with how it came out.